Welcome back. We're going to now work on another example of the Poisson distribution. The Poisson distribution must meet certain criteria. First is that the events are independent of each other, meaning the occurrence of one event does not affect the probability another event will occur. The average is known and it remains constant. Two events cannot occur at the same time. In this example, we are studying customer arrivals at the airport. We are told that on average, 24 customers arrive at the airport. We're going to find the probability of exactly 10 customers arriving during a given time. In Excel, we're going to make use of the Poisson distribution function. When you open the Poisson distribution, the first argument asks you for the x value. The x value is the number in your question. Here it is 10. The mean as per our question is 24. Here, since we're looking for exactly 10 from the two choices given, we're going to select false. Our second question is asking us to find the probability of more than or equal to 5 customers arriving at the airport. The function to use in Excel is still the Poisson.dist function. However, there is an additional step that must be done. Since we're looking for probability of x being more than or equal to 5, we are going to first find the probability of x when it's 4. Mean is 24, and we're going to use the true statement. The true statement basically tells you the area under the curve all the way until 4. Once you find this value, you're going to deduct it from 1 because the area under the curve is equal to 1. So 1 minus the answer you found equals to 0.99. I'm going to go ahead and reduce the decimal place to 4. In question number C, we're going to find the probability of x when it is less than or equal to 25. So in Excel, we're going to use the Poisson.dist function. X is equal to 25, mean is 24, and here we're going to use the true statement. The true statement gives you the area or the probability on the left hand side until the x value given. So here it is 25. So since we're looking for probability when x is less than or equal to 25, we're going to use the true statement. I also recommend that you watch the other videos that I've posted under the playlist, which shows you the bell curve, shows you different ways and different functions to use in Excel to find the area under the curve. So here the answer is 0.6319. In part D, we're finding probability between 10 and 30. So here it's basically asking us to find the probability when x is more than or equal to 10 and less than or equal to 30. So here when you're looking for probability when x is more than or equal to 10, we're going to find the probability of x when it's equal to 9. We're going to find the probability using the Poisson.dist function, and we're going to subtract them from each other. We can do this at one go. So equals to Poisson.dist, and here I'm going to use the 30, mean is 24, and we're still using the true statement, minus Poisson.dist, 10, 24, and true statement. So the probability when x is more than or equal to 10 but less than or equal to 30 equals 0.9031.